Visit us at EduVo. Thank you for calling EduVo.
Now the topic is arrays. See, arrays are useful for storing collection of data items, collection of elements. Usually in our program we declare the variables like this: integer n or float a. If you declare any variable, then these variables, the purpose of these variables is for storing a single value. And if you look at the memory, how it is allocated for n, if I say integer take 2 bytes, 2 bytes are given, and the float, if it takes 4 bytes, so then 4 byte of memory is allocated for a. And that is useful for storing only one value at a time. So if in n I am storing 15, then there is only one value in this one. But suppose in your program you have to store some set of values, collection of values, then we use array of data items. So this is for just one value, but if I declare integer of type array of size 5, so this is data type, this is the name of an array, and this is the size of an array, 5 elements. So I'll be getting the space for storing 5 integers. Then how it looks like, this A will look like with the 5 integers. So I can store 5 elements in this one. Now if I draw it here, array looks like this. Each location can be accessed with the help of its index. So this is A of 0, A of 1, A of 2, A of 3, A of 4, so on. If I talk about addresses, suppose these 2 bytes are having address, they are also having address, then what about the array addresses? Suppose this is starting from 300, as this is integer, so let us say 2 bytes, so 300 and 301, and this is 302 and 3, then 4 and 5, then 306 and 7, this is 308 and 9. So each is taking 2 bytes, so the size of this is 10 bytes in terms of memory, and each byte has its own address. So all these bytes are contiguous, they are side by side. So all these locations are side by side only, so we can access them with the name and the index. Suppose here I have to write down value 15, then I should say A of 3 assign 15. So at this place 15 will be stored. So if I show it in this is 15. So I define array once again. Array is a collection of data elements under one name, and each element can be accessed with the help of its index, and all the memory locations will be contiguous. Let us see what are the ways of creating and initializing an array. First is, if I declare an array of size 5, this is what we have seen just now. Then other way, I'll use the same name, I will not write different name. I can create an array like this also by initializing it 2, 6, 7, 9, 5. So what happens here is, I'll get an array with all these elements filled. This is 2, 6, 7, 9, 5. So this is initialized with these elements. So declaration of an array as well as initialization of an array. Now instead of this, I can also say A 2, 4, 6, 8. Here you can see I have not mentioned the size. Then the size of an array is decided depending on the elements I am initializing. So I am initializing 4 elements. So the array that will be created will be for 4 elements, and 2, 4, 6, 8, 0, 1, 2, 3. So this is how the array is created. The size of an array is decided depending on the number of elements assigned to it. Then one more method is, I am creating an array of size 5, but I am initializing just 2 elements, 2 and 4. So here the array of size 5 will be created, but the elements will be 2 and 4. Then what about the rest of the elements? They are automatically initialized to 0. So it means if I declare an array A of size 5 and I just say 0, then what happens? The first value will become 0, and automatically rest of all the values will become 0. So these are the various ways of declaring and initializing an array. Let me repeat quickly. Declaration of array, declaration and initialization, declaration without size and initialization, and this is declaration and partial initialization. This is also declaration and partial initialization. When partial initialization is done, the rest of the elements will automatically take the default value, that is 0. Let us see the different types of array. So if I have an integer type array A of size 5, I can initialize it with these elements 2, 5, 8, 10 and 16. This is the integer type array. I can take a float type of array B of size 5, then I can initialize float numbers 12.6, 5.9, 3, 8.2, 6.7. So I have taken some float numbers. Though for the numbers I have not given f here, so by default compiler will convert them into float type, and even I have given an integer value that will also get converted to float type because the array is of type float. Now what about character type array? I will take a character type array, and in this I have to mention all character literals. So this is A and this is B, C, D and E. So every character literal must be enclosed in single quotes. So this is how we can take different types of array, different data types. Next we will look at some programs on arrays, how to use them. Here let us learn how to declare and initialize and how to use an array. So let us learn some array basics. If I want an array of type integer, let us call it as A of size 5. So I'll be getting 5 integers starting from index 0 to 4. It is not initialized, I have not assigned any values. If I want to display this, I'll be actually getting garbage values. Let us try this and see how to display this. For going through all the elements of an array one by one, I should have a counter. So where I will use it as a counter, I assign 0 and I is less than 5 because the indices are from 0 to 4. Then I plus plus, and here I will say cout A of I, and also I will write NL after printing this one. Let us run this and see what happens. See, this is initialized with few values are 0, 4 values are 0 and one of the value is a smaller negative number. So all these are garbage only because the array is not initialized. How I can initialize an array? One method is I can initialize an array by assigning some values like 3, 4, 10 and 12 and 5. Let us run this and see. Now I got the same values 3, 4, 10, 12 and 5. So this is the way an array can be initialized. I'll remove these values. The size of the array is 5, but I am giving only 2 values. Let us see what happens. See, 3 and 4 are there and the rest of the values are by default 0. See what happens when you are initializing an array. You need not initialize all the locations or all the integers of an array. You can initialize few. So rest of them will be automatically initialized to 0. If I say just 0, then what happens? All of them will get 0 because the first one is 0 and remaining all of them automatically become 0. Yes, all these are 0. Now if I give some values here 2, 4, 6, 8, 10, I have given 5 values here. Can I exceed the number of values? Let us see what happens. I have given one extra value, so it's a compiler time error. So it gives an error that excess elements in an array initializer. You cannot have number of elements more than the size of an array. So I should give the array size as 6. Now let me run this array and see for 6 elements. Yeah, I am getting all the elements. If I don't give the size here, will it allow? Yes, this is another method where you don't have to give the size of an array, just you can give the set of values and the size of an array will be exactly equal to the number of elements that you are mentioning in the list. Let us run this and see. Yes, it's working as there was no error, so the size of an array is 6. Now next I have to show you one more type of for loop that is called as ForEach loop, that is mostly useful for array or collection type of data structure. So here int x I'll take one variable x, and that is for a, and C out x and also endl. See, this is declaring a variable x for the elements in a. So when you say when we say for, this will be iterating through this array for all the elements one by one, and each element will be taken in x every time. So first 2 will become x, then 4 will become x, then 6 will become x, and goes on. So in this way it will iterate through the entire array, whatever the size may be. So we don't have to know the size of an array. This will take care, this for each loop will take care. So let us see, it will display all the elements. Yes, this is working. It is same as that. Now here I will take the size of an array as 6, and I will give only 3 elements. Let us see what happens. Will it go through all 6 elements or just 3 elements? It's going through all 6 elements. So it means this for each loop will work according to the size of an array, physical size of an array, not based on the number of elements stored in an array. We have not stored remaining 3 elements which are initialized to 0, but it is displaying the complete array. So this is a very useful for loop. This was introduced in C++ 11, version 11. So this for each loop is a part of modern C++. This was not there in old version of C++. This was introduced in C++ 11, and this is a very useful loop for accessing arrays. If I have a float type array, then I can initialize a float type array by giving some float numbers 2.5f and comma 5.6f comma 9 8 7. So some of them I have given float literals and some are integer literals, so I can use any of these. Now here, when I am taking integer for a, let us see whether it works or not. But this x should be of type float because these are float values. Yes, it's working, and it is truncating the decimal part and taking only integer parts of these numbers. Now here, actually I should write float, then it works perfectly. Yeah, I'm getting all the values as it is. So I'll got the correct values. Now instead of giving float, even I can write auto. So I don't have to know what is the type of an array also. Just auto x, I can give the array name. So it is very powerful and very easy for the programmer. He don't even have to know what type of array he has declared. He don't have to go up in the program and check the type of an array. So now x will be of type float. So you can see that I am getting the values 2.5 and 5.6 and so on. So this x is of type float. If I have to declare an array of type characters, then it must be initialized with the character literal. So I can store a, and for b I will take 66, and for c I'll take c, and d I will take it as 68. So let us see what happens when I print this using for each loop. Now here x is auto, so it will automatically take it as a character type. Yeah, A, B, C, D. Though I have given ASCII codes of letter B and letter D, I am showing it as character, so it is displaying them as characters. If I take them as, instead of auto, I will write it as integer, and let us see what happens, what values I get. Here I am getting 65, 66, 67 and 68. So it means these are the ASCII codes I have converted into integer. So these elements are taken as integer type and displayed here. So that's it about arrays. So you practice this thing, just go through it and test it by yourself.
Let us write first program on array. Suppose I have an array with some elements in this.
I want to display all these elements on the screen one by one. So first where I should go, a of 0, then a of 1, then a of 2, one by one I should display all the elements. So for going through this one, I need the indices. So for that I will take one index pointer, that is I. I is 0 initially, so this means a of I is what? 2. Then I will change it to 1. Then a of I is what? 1 now. So a of 1 will be 8. So a of 1 is 8 because I is 1 now. Then next I can become 2. So a of 2. So I can just use a of I and I can keep on changing the value of I. So you know very well that for loop can be used for making the counter. So I is acting as a counter. So let me write on the piece of code for displaying all the elements of an array. I will declare one array here and also initialize it with these elements 2, 4. Then using for loop, I will take integer I. This should start from 0 onward. So it will start from 0 and it will be stopping at 5, means continuing till 4. So this is less than 5 because the last index is 4. Then I plus plus. Then here simply say cout a of I and L. So this will be displaying all the numbers one by one from a of 0 to a of 4. Next, let us write a program for finding the sum of all the numbers in an array. So I want to add all these numbers. Already we have written this program for displaying this. Now I will add them. So for adding, I should have some variable sum. This is 0. Then what I should do, first add 2. Then sum becomes 2. Then in 2 I should add 8. Then sum becomes 10. So how you can do is, every time in sum I should add a of 0. Next a of 1, then next a of 2. So it means I should add a of I in sum and store the result in sum. Now you must be familiar with this type of statement. So sum will be initially starting with 0, 0 plus a of I. So instead of displaying, simply I will write here sum assign sum plus a of I. And here I need one variable sum, and that should be initially 0. Now with the running of this loop, I'll be adding all the elements one by one added in sum, and the result after the loop I should display the result cout sum. This is the method for displaying all of them. Let me trace this also and quickly show you. See, I is one thing and sum. So I is initially 0, sum is initially 0. So what is happening? I is 0. So 0 plus 2 is added and the result is 2. Then I is 1. So 2 plus 8, this 8 is added and the result is 10. Then 10 plus this 10 is added and the result is, the next is 2. So this is 10 plus this 10, a of 2, this is added and the result is 20. Then next is 3. So this is 20 plus this number 12 is added and the result is 32. Next I is 4. So this is 32 plus 16 is added. So this one, then this becomes 48. So what is happening here? I is incrementing one by one every time, 0 to 4. Then when I becomes 5, it will stop. Then what is happening here? This is sum plus, what is this? A of I. This is a of 1. This is a of 2. Then this is a of 3. So this portion is a of I, and that is added to sum, and the result is stored in sum. So this is what we have written here. Let us write a program to find the greatest number from an array. I have taken the numbers here, and here the number I have taken that is largest, that is 20. Now that's what we have to find out. So for that, what I have to do is I have to go through the entire array by taking one element at a time, so that I can help me. I can say a of I. A of I will give me the numbers one by one, and this I value can change using for loop. Now what I have to do every time? If the number is greater, I want that result, I want that value. So initially I should have some variable called max, and in that let us store some smallest number, that is -32768. So I can have some smallest number. See, when you can say something is bigger or maximum, if you can compare it with some smaller number. So that's the reason we are taking some smallest number. It must be initialized with some number, so I am initializing it with the smallest integer. Then every time a of I 2, is it greater than this one? Yes, it is greater than max. Change it to 2. Then 8, is it greater than maximum? Yes, maximum is not 2. Change max to 8. 20, is it greater than maximum? That is 8 now. Yes, change it. Now 12, is it greater than maximum? No, don't change it. 16, is it greater than maximum? 20, no, don't change it. So it means if any number a of I is greater than maximum, modify it. So the code will be same, simple only. This is an array and this is a loop. I need one variable integer max, and that max value I will store it as -32768. And every time I should check that a number from an array is greater than max. If it is greater, then change max to that number, a of I. Then outside this, once you have finished with all the elements in an array, print max on the screen. That's it. Let us write a program to search in an array. Suppose there is a list of elements in an array. I want to search for a key element, that is 12. I know that 12 is there, I can see it, but I want to know its index. So searching. So there are two methods of searching. Now I will tell you one thing. Let us know what are the methods of searching. See, there are two methods of searching. One method is called as linear search and the other method is called as binary search. So for the first method, this array is sufficient, but for binary search, this array will not work. We have to first of all sort the elements. Binary search can be performed only on sorted elements. So let us perform linear search on this one. What is the method? See, we have to go through the entire array. So for traversing array, we can use a for loop and go through all the elements by changing value of I. A of 0, a of 1, a of 2, I will be taking us through these elements. Now every time what I should see, a of 0, is it the element that you are searching? No, that is 2. Move I. A of 1, is it the element that you are searching? 12, no. Then a of 2, is it the element that you are searching? This is 20 and this is 12. No, that is not same. A of I, is it the element that you are searching? Yes, this is the element that we are searching. So stop there and say the element is found. So let us write on the piece of code for this one. See, I will take one value, that is key, and C out, enter key for searching. Enter key. Then C in, take a key. So using loop we can iterate or traverse through this array. So for integer I assign 0, I is less than 5 elements are there, so I plus plus. Then every time check if the key element is equal to a of I. If it is found, then I can say C out found at, it is found at I. And once it is found, I should also exit the program. So I can say exit 0 to stop the program. If I came out of the for loop, that means element is not found. So say C out not found. That's it. This is for searching for a key element in an array. So like this, a lot of operations can be done upon an array. Some of the programs I'll give you exercises and some of them I'll show you practically. Let us write few programs on arrays. I will take one array of size 10 and I will store some numbers in this one, 2, 4, 6, 8, 12, 3, 5, 9. Now the first program, I will find the sum of all these elements. So for that I will declare one variable sum which is initialized to 0. Now I have to iterate through all these elements one by one, and every element I should add it to sum. So one of the loop that will take me through all these elements is a for loop for I assign 0 and I is less than 10. I plus plus. So every time sum assigned with the sum plus a of I. So this will be storing the element in sum. So this will be adding a element with the sum and storing the result in sum. So I don't have to give the brackets also, because it's a simple statement in a loop. Then simply I will write cout sum of all elements is sum and L. Let us run and see. Yeah, sum of all the elements is 67. So if you add all these, you will get 67. So that's it. This is a program for finding the sum of all the elements in an array. Now I have another loop that is called as ForEach loop. So I'll just try this with that ForEach loop. So int x from a. So here I will say x. So let us run and see. I have just changed this with x. So x will be taking the values like 2, then 4, then 6, and so on. And every element is added to sum and the result is stored in sum. Let us run the program and see. Yeah, same 67 I got. Now here you remember that, and here if you remember, instead of writing int, I can also write auto. This x will automatically become of type integer because we are taking the elements from an array A. Let us run this and see. It's not a syntax error, it's running perfectly, and the answer is 67. So I can use for loop, or even I can use for each loop for finding the sum. Now let me modify the same program for finding the maximum of all these elements. So the maximum element you can see that is 12. So I want to find out that maximum element. So for that I should already have one variable max, which should have the very smallest value of type integer. So there is a constant available that is min, that is int min. So I should have a smallest number with myself, and here inside this for loop I'll use brackets. Now if x is greater than max, see here I have taken a smallest integer inside max. So if I get even a single value that is greater than minimum integer, that will be taken in max. So what I'll do is, if x is greater than max, then I will store that x in max. So max assign x. That's it. I wanted only one line under this if, so even I can avoid this bracket. So now let me display the results. Cout maximum number is max and L. Let us run the program. I should get the answer 12. Yes, I got the answer 12. Let me show you the reason why I am taking int min, that is minimum of integer. Some students think that why can't we take just 0? So I'll just take 0 and I will make all these numbers as negative. Now tell me, now check here which is the largest number. So the largest number is -2. All numbers are less than -2, but here I have taken the initial value as 0. Let us run and see what answer I'll get. See, the answer is 0 because the maximum number was, we have taken it as 0, and that 0 remains as it is. None of these numbers are greater than max, so this condition never met, so the value of max is never changed. So if you want to consider positive numbers as well as negative numbers, then go for minimum integer value. Int min is a built-in constant in C++, so you can use this for getting the minimum integer number, that is -21, 47, 48, 36 and 48. That's it. So now let me change quickly the program for finding the minimum of all these numbers. So you can see that the minimum for all these numbers is -12. So I want that one. So I'll change the variable name to min, and wherever it appears I'll just change it to min. Now what is the other change I have to do? After making this all as min, this condition I have to change. If x is less than min, then change min to x. And here, instead of minimum integer, I should take it as a max integer. Let us run and see. I should get the answer as -12 because that is the smallest element in the list. Yes, -12 is the answer. So this is the smallest element that is there in the array. If I remove negative numbers and make them as positive, now one of the number I'll make it as -3. So I should get the answer as -3. Let us run this. Yes, the minimum number in an array is 3. So that's it. These are the programs for finding the maximum of the list of elements in an array and minimum of all the elements in an array, and also we have seen how to find sum. Now I will modify this program for searching an element in a array, that is list. So I'll use linear search. So I'll remove all these things, let the array be as it is. Then I have to search for a key element, so I will take one more variable key. Then I will ask a input, that is enter a key to search. I'll ask the user from the keyboard. I will take the input, the key value. Now I will search for this key value inside this array. So I can use for loop, I can use for each loop, any one thing I can use, and even I can use while loop. So I will use for loop here. Integer I assign 0, I is less than name. Now here I can use for loop or for each loop, but actually I want the index. Suppose I am searching for 12, then 12 is at index 0, 1, 2, 3, 4. So it's at index 4. So I want the index of that element. So I cannot use for each loop. For each loop doesn't work based on indices. So I have to use for loop here. Integer I assign 0 and I is less than 10, I plus plus. Every time I have to check whether that key element is equal to the element in an array at a present index I. If so, then I will say cout element found at, I want the index, right? So I will say I, it is found at index I. Then this I will give it in brackets. Now once it is found at index I, then what I should do, I should stop the program. So I will say just exit 0. So this will terminate my program. I should not continue further at all. If I have came out of the for loop means the element is not found, then here I can say element or say key element not found. So if I have finished the loop, then it means the element is not found. Otherwise the element is there in an array, it is found here, and I can display the index here. I am displaying an index, then it will exit. Let us run and see. Oh, typing mistake in enter. Enter a key for search, so I'll give the search key as 12. So you can see that the index I got is 4. I'll run once again. Here I'll give endl. When it is found, I'll give it as endl. So I get a space endl. Enter a search key value, so I'll give the C key value as 11. So it is found at index 9. I'll run once again. Now I'll give the element as 31. So the key element not found. So it has checked everything and it has came out. That's it. You can try this program by yourself and also try to debug the program and see how it is working.